Welcome to your Get That Nugget for GCSE Maths. Today we will be concentrating on giving you a framework to answer grade 3 style drawing linear graph questions. It's all about drawing linear graphs. Please note, this session is to complement your lessons with your teachers. It is not to replace them in any way. So for these questions, you will need a pencil and a ruler because you're going to need to actually draw the graphs. So let's have a little look at how these questions are going to look. I'm going to zoom in. What you will find in the exam question is it will say draw the graph of, and it will give you a region. So for this question, it says from the values -1 to 3. Now, the grid will normally be pre-drawn, so I've drawn it for you. I just bring your attention to the graph, the axis first. You can see that the y-axis, the vertical one, goes up 1 square for every 1. But just take note on the horizontal, the x-axis, that it's 2 squares for every whole unit. So just be really careful with the scale. Okay, so this is my equation that I need to use to be able to draw the graph. And I'm given the information from -1 to 3. In lots of questions, they just give you that and then the axis for you to draw the graph. There's not much else you need to do. So the first thing you're going to want to do, without any prompting normally in the exam question, is you're going to need to draw a table of values. I'm going to write that down so you've got that table of values. They don't always give one to you in the exam, and it can be a little bit confusing as to where you start. So what I'm going to have is I'm going to have a table of values. Now it links very closely to my graph. I've got X and I've got Y. So guess what's going to go in my table? X and then Y. Now it tells me the values of X that I want. I want from -1 to 3. So I'm going to go from -1 all the way up to 3. And you notice in my question there, I've just left a bit of space between them so I don't get too confused. Now, it says draw the graph of y equals 2x. Well, it's telling me to get y, I have to do something to my x value. In this instance, it says 2x. Now, hopefully remember that a number in front of a letter means to multiply. So what this wants me to do is to multiply my x values by 2. So whatever x value I've got, to get y, I simply double it, or I times it by 2. Now my advice, always start with a positive if you can, because we don't want to make a mistake with this negatives. So if x is 3, 3 times 2 means that's going to be 6. If x is 2, well, I need to times it by 2. Well, 2 times 2 is 4. When x is 1, well, again, we've just said all I need to do to get y is multiplied by 2. So 1 times 2 is 2. Don't make a silly mistake on your 0. 2 times 0 is always going to be 0. And then the last one, when x is -1, what's -1 times 2? Well, that's going to be -2. And you can see the pattern because it goes down by 2 each time. Now, lots of people stop there. It's really important that you don't, because it very clearly says draw. And we've got an axis for which to draw our graph from. So I'm going to switch to a pencil, because if I make a mistake, it's easier for me to rub this one out, should I need to. So what these are my sets of coordinates. Now, again, similar to before, I'd always start with the positives, because then it's obvious if I've made a mistake with the negatives. So what you do, my x value is 3 and my y value is 6. So I'm going to go along the corridor 3 and then up the stairs to 6. The next one, along the corridor 2, up the stairs 4. So along 2, up 4. Along 1, up 2, because as I said, these are all of my sets of coordinates. Next one, 0, 0. So I'm going to go through what we call the origin. And then my last one is -1. So -1 along the corridor and then 2 down. So that should look like that. Now, the clue when you draw linear graphs is they should be a line. And the amount of people that would leave that, you haven't drawn the graph. All you've done is you've plotted it. So it's really important I join my graph from those endpoints that I've plotted. And then what I should notice is when I draw my graph, it's a lovely straight line that goes through all those coordinates. If there's a random one that doesn't seem to sit correctly, there's a good chance I've either done the calculation wrong up here or I've plotted it the wrong way around. But we're happy. Table of values, graph plotted, line drawn. Perfect. Okay, let's up the ante a little bit and try this question. So we are now, and I'm keeping the scales the same so we're not too confusing, and the axes are all the same, just so it's nice and consistent for you. So draw the graph of y equals 3x minus 1. From the values of x, -1 to 3. Again, no table of values, so we know that the first thing I'm going to do, I'll get a pen so it's nice and clear, is I'm going to do my table of values for this one. So I'm going to go across, going to go a bit higher this time, a bit further along. X and y, what's it want me to go from? It wants me to go from -1 all the way up to 3. Now, what's the equation I've got this time? Well, this one, it's saying to get y, it's 3x minus 1. Well, what that means is I have to multiply x by 3 and then subtract 1. A little bit out of focus, but hopefully you can see that now. So to get y, I times x by 3 and then I minus 1. So that means multiply by 3 and then subtract 1. So what I do is I put it into my table. I use my table and plug those values in. And again, we start with the positive. So in this instance, we're going to use x is 3. So here, 3 times 3 is 9. Take away 1 is 8. For this one, we're going to use x is 2. So what I do is I know the equation here is to multiply by 3 and then subtract 1. So 2 times 3 is 6, minus 1 is 5. This one, x is 1. 1 times 3 is 3. Take away 1, or subtract 1 is 2. 3 times 0 is 0. Take away 1 is minus 1. And then the last one, just be careful, minus 1 times 3 is going to be minus 3. And then we're going to get more negative because we're subtracting 1. So that becomes minus 4. Just check your pattern, see if it looks okay. And we'll know when we plot the graph as well. It seems to get more negative as we go left. So now I'm going to grab my pencil and I'm going to plot that point along 3, up 8. I'm now going to plot this point along 2, up 5. I'm now going to plot this point along 1, up 2. And I'm now going to plot this point, which is don't go left or right anything, and I just go down by minus 1. And then the last one is minus 1, minus 4. Now, what I'm hoping for, again, we're drawing linear graphs. I need to draw it. I've plotted them. That's all I've done so far. So now it's important that when I do this, I actually finish drawing the graph, and I've drawn them from my minus 1 for x all the way to 3. And I can see they go through the points. I'm happy. Table of values, plotted my points, drawn my graph. I've drawn the graph. So we're happy with that one. Okay, how can it get more tricky? Well, to be honest, probably bringing in some negatives. So again, we need to draw this graph, and it's from the values minus 1 to 3. So haven't changed any of that. We're still going to do the same process. There's no table of values. Well, I know I need sets of coordinates to draw a graph. So here's my x, here's my y, and we're going to go from minus 1 to 3. So we're going to go across to those. Now, just have a look. What does my equation tell me to do to get y? Well, it tells me that I need to multiply x by minus 2 this time and then add 3. So what I'm doing is I'm multiplying my x by minus 2 and then I plus 3. So it's made a little bit tricky because of the negative. So that's the operation we need to think about doing. So I'm going to start with positives. So we'll start with the positives first. So when x is 3, I need to do 3 times minus 2. Well, 3 times 2 is 6, so 3 times minus 2 is minus 6. And what's minus 6 plus 3? Well, minus 6 plus 3 should be minus 3. And then when I've got 2, if I multiply 2 by minus 2, that should give me minus 4. And then when I add 3 to minus 4, I should get minus 1. When I've got 1 for x, well, 1 multiplied by minus 2, well, 1 times minus 2 is minus 2, and then plus 3 gives me positive 1. Don't know why I've done that one that way around and not this one, so it's for consistency. When x is 0, what's 0 times minus 2? Well, that's always going to be 0, plus 3 is going to give me 3. And then the last one, I've got a minus 1 times minus 2. Well, two negatives when I multiply should give me a positive. So 1 times 2 is 2. So that's going to be positive 2. Positive 2 plus 3 is positive 5. If at any point you're not sure about where those numbers have come from, just down here for the first one here, just so you're clear, what I've done is I've just swapped x for whatever this value is. So here I'm going to do 3. So to get this number, in case you need to see it nice and clear, all I've done is I've done 3, and I've multiplied it by minus 2, and then I've added 3. So I know 3 times minus 2 is minus 6. So minus 6 add 3 has given me minus 3. So that's where that's come from. So it's all about using the equation up here and then plugging those values in to get your coordinates. And then what you're going to do is you're going to use this set of coordinates. So along the corridor 3, and then down 3 because it's 3 minus 3. This one along the corridor 2, and then we're going to go down 1. Again, I'm taking care of my axis. I'm 2 along, 1 down. The next one, 1, 1. So along 1, this time I'm going up 1. This one, 0, 3. So we're not going along the x-axis at all. We're just going up 3. And then here I've got minus 1 on the x-axis. So that's minus 1 here. And we're going to go up to 5. So that's going to be over there. I've plotted. I'm hoping to see a straight line. Do I see a straight line? Yes, I do. So what I can do is I can join those up to draw my line from minus 1 to 3. So yeah, I just put this example just so you can see where those numbers come from, because I knew I did them in my head, but I wanted to be nice and clear. I was explaining what I was doing, but hopefully you can see that. And then there's one more type of linear graph that you may well get. Still a linear graph, but it's a slightly different form, and sometimes this can throw people. So draw the graph of x plus y is 8 from the values. So still drawing a graph, still need those same values. So we're still thinking about the fact that we need a table of values to be able to plot anything. So x, y, we're going from minus 1 to 3. Now, these look more confusing than they actually need to be, because we've got it round the other way. It's not like y equals like it was in the previous 3 examples. It's x plus y equals 8. Well, actually, that makes the question easier in my eyes for this question in particular, because all I know, all the question is telling me is when I add the x coordinate and the y coordinate, or the x value and the y value, it gives me an answer of 8. So again, starting with the positives. Well, if x is 3, if I made x 3 up here, what would I need to add to 3 to get 8? Well, 3 plus what is 8? Well, that would just be 5. If you think about this one, if x is 2, what would I need to add to 2 to get 8? Well, it would just be 6. 2 plus 6 is 8. 3 plus 5 is 8. 1 plus 7 is 8. When x is 0, what do I add to 0 to get 8? Well, that's going to be 8. The only one that's a bit tricky is this one. But if you look at the pattern, 5, 6, 7, 8, I'd assume that would be 9. Because if 9 and minus 1, what's 9 minus 1? Well, that's also going to be 8. So it looks confusing, but when you just plug in the values to get an answer of 8, it becomes relatively easy. There's no complex calculations. Now it's a case of plugging them in. Along the corridor 3, plot that one, up the corridor, up the y-axis 5. Next one, along the corridor 2, up the stairs 6. Along the corridor 1, up the stairs 7. Along the corridor 0, up the stairs 8. You can see that my axis isn't the best because I've gone off. I actually go as far as 9, but when it comes to the question, it'll be nice. The axis will go as far as you need to, but for this question, it's nice and clear. We can see that I would have a straight line and it would go through these points. So your scale would go across. So if mine did, it would just go to here, and you can see that would make a straight line. So yeah, I just want to show that example because they do come up infrequently, but they do, and I don't want it to throw you. Use the same process, table of values, from the values you need, what gives me 8 for that specific question. Okay, so there's hopefully a bit of guidance on how to draw linear graphs. Tend to be sort of, 4-mark questions particularly. So what you've got is, again, I've not changed, I still all want them from values minus 1 to 3. And then what you're going to do is work through those. So a nice combination of graphs in terms of the x plus y and then those two others. So you'll need to do the axis, but I would say do your table of values first. That tells you how far to draw the x-axis and how far to draw the y-axis. Excellent.